All right, welcome back. We are Game 3001 in the winter 2021 semester, and it's week 12, actually, part 2 of our broadcast. And we're going to be talking about our Lab 9. Let's take a look at what the Lab 9 goals are for today. We got lots of stuff going on. We're going to create a Pathnode class, and we're going to make some changes to the game object superclass as well as the scene superclass to accommodate. We're going to be doing a lot of little things. And why? Because I want to help you guys with one key item, which is this line of sight from each path node, right? So what this is going to help us do is kind of create the ability for your ranged combat enemy to go in and out of cover, for you to know from each of the nodes that you're visiting what their status is on line of sight. And as soon as we have line of sight status from each of the nodes, then you'll be able to navigate throughout the entire map. Okay, so that's kind of how it is. And so that's what we're going to be working on today. All right, let's get going. So again, just like we've talked about last time, we're going to start with a Lab 9 starter, which is just the previous Lab 8B. So we're going to download that, which I've already done. I'm going to just take this offline for a second, and we're going to get going on that one. So under the desktop, here we are, Game 3001, W2021, Lab 9A. Let's do Lab 9B. So I'm just going to extract here, so like we always do, so nothing new there. And let's make this Lab 9B. Okay, 9B, there we go. We don't need this anymore, we can get rid of it. And what we want to do is start off with our previous lab. So basically what we're going to be doing is we're going to make it so that it's going to help. Again, every lab that we try and do, Alex and I, it's an attempt to assist you with your assignments. Okay, that's what it's for. All right, so assignment help more than anything else, as well as teaching some new concepts in terms of coding or AI or what have you. So this is the idea behind it. Let's get going. All right, so so we've started this. Let's launch. I always try and launch the project like normal, just to make sure that things are good, so things are working from last time. Because if it's not a working project and you're going to start with a lab, that's not going to be okay. And then, you know, we're going to have false expectations. So let's get moving on this one. And I'll wait till this is ready to go. It's ReSharper's doing its tricks. And then hopefully we'll have a window pop up very shortly. And then we'll put this up on GitHub, which will help you all with kind of a baseline. All right, looks like it's launching finally. And we're good. This is what we had last week. We had this performing patrol action. Awesome. All right, so that's this. Excellent. Let's do a couple things. First, in the docs area, let's go to README. The one from 5 minutes ago. Not sure. I don't know if I put one up 5 minutes ago, but okay. 3S1 Lab 9 is what it should be. There we go. There's Lab 9. And then what I'm going to do is I'm going to add to source control. Let's add this to source control. And when we do that, we're going to basically have a git add night. Yeah, Lab 9 starter. That's the one you want. I'm going to go to publish on GitHub, which I'm going to choose George Brown College. And I'm going to go to Lab 9B, right? And then we're going to publish. So that is your starter. So that is your final. This is your final version that I'm going to produce. I'm going to give you a link for that in a second. So let's go back up online here and refresh. So you should have 9B, which is really your final. All right, that's the final version. So that is the one. I'm just going to grab that link for you guys, and that's the one you can compare with your lab compared to my lab to make sure you've got everything that I've got. And I'm going to be coding this live as always. So Lab 9 final. Okay, excellent. And we'll just pull this one up. For those people who are watching the video, let me know if you need anything as we move forward. Okay, so let's continue. So So as we talked about, what I want to do is create a Pathnode class. And I think the trick with the Pathnode class is what we're trying to accomplish. We've had several classes in the past, but the idea is maybe it's the agent class we want to create, because the Pathnode class, if we investigate a little bit, kind of does exactly what our agent class does. All right, so let's take a look. It's not quite an agent is what we're making, but it does a lot of the work for us, right? So contextually, not 100% correct. Functionally, we may have a pretty good solution. All right, so this is one. First things first, though, we want to clean up our scene that we have like normal. So I'm going to go to the playscene.cpp, and I'll make a couple of changes. All right, so the first change I want to make is inside of the, I'm just going to point to the start. There we go. Under start, I want to disable our state machine. Okay, so no more state machine for now. Let's get rid of that. That's not the subject of today. Okay. And the other thing we need to do, because we're disabling the state machine, is we don't want to update it anymore. So that's something that we want to remove, right? So let's remove that state machine update. Okay, that's for sure. So we're not going to do that right now. We're going to leave the code in place, because there's no need to just work involved removing it. So we'll leave it as is. But what we want to do at this point is we want to create our Pathnode class. So that's first things first. Let's also do some disabling. One of the things that we're going to have to do for today is the ability for us to turn on and off the visibility. So one of the things we need to do is when we turn the visibility on and off, how do we do that, right? I want to be able to show the path nodes and hide the path nodes. I really don't have that capability right now. And this is where I need to change the path node or the game object class for game object and the scene. Okay, so that's the first thing I want to think about doing. How will this function? And we're going to do this before we actually make the path node class. Okay, so it's the first thing we're going to do. So what do I mean by that? Well, let's take a look at how things work right now. Okay, so we're going to go into our game object superclass. There's our game object. And in our game object superclass, we have a few things. One of them is this enabled Boolean, right? This enabled Boolean. What I want to add here is a visible Boolean. All right, so enabled is different than visible. Enabled means that the actual game object is in the scene and working. Okay, it doesn't mean necessarily that it is visible or invisible, although it means both actually in some ways. If I disable a game object, what I want to do, just like we do in Unity, is remove it from the scene hierarchy temporarily. But I want to do something different with something that is visible. So the first thing I want to do is just add in a Boolean that says visible. That's the first thing. And that's in the game object superclass. So I'm actually changing all the classes that derive from it. This is pretty dangerous. Remember, there's a cascade of classes that come from game object, all right? Display object, agent, other ones, right? So let's move to see what we need them for. Well, we need to set a couple of getters and setters, and we need something that is a void set visible, where we're going to pass in a Boolean state, and a Boolean is visible, where we can check to see if an object is visible or not. Okay, so those are the two things that we're going to add in. Okay, and we're doing this to support the visible, not visible thing without removing functionality. All right, that's what we don't want to do. We don't want to, and I'll explain how this works in a second, right? But that is the first thing we want to do. All right, so the first thing I want to do is I want to, kind of put those in place. The next thing we want to do is we want to kind of create the implementations for these. So generate implementation for this one, set is visible, as well as is visible. So make sure that that is also implemented, those two things. So how does this thing work? Well, we know that m underscore visible is equal to state, right? We can make this a const. All right, so we can do this const stuff. And we're also going to say that we're going to return m underscore visible. So some way of tracking visibility. So when you're not visible, you're hidden. When you're visible, you're seen. That's the idea behind it. But it's different, right? Because we can have an object that's visible and yet, invisible, but still running in the background, not being rendered though. So we can turn off the renderer for a display object. That's the idea behind this. Okay. Okay, great. So we've done the changes in our GameObject.h. Let's put this up on GitHub. So we're going to say that, actually, let's change the scene and then we'll do the whole function. All right. So the next piece is the core under core scene.h. That also needs some modification. So under scene.h and scene.cpp, I want to point out how this works. So the scene, what it does is it has a list of display object pointers. And what this list of display object pointers does is it updates itself during the update display list and draw display list. All right, so if I go to definition for these, go to definition, you can see what I've got. I've got a couple of for loops that run. And right now the way it works is if this object, which let's rename these so they're more reasonable. So we're going to change these names. So refactor, rename the one in update display list. We'll call this display object because that's what it is. And we'll do the same thing here so we know what we're talking about, just so that we're clear. So refactor, rename, right? And we'll call this also display object. Nice and easy. What I want is, so this is saying if display object is not enabled, then break out of this. We don't want to even display this object. We don't want to even go here, right? I want to change this up. So it's going to say something that looks like this. It's going to say the only way that I'm going to draw from now on, right? The only way that I'm drawing is if both the display object is enabled, right? The display object has to be enabled and my display object is also visible, right? So those are the two things, the two states I need to check. So both of those two things are going to be something. So if one or the other is false, then it's not going to display anything, okay? And this can be good and bad. On the good side, we have some flexibility. On the bad side, we may not get anything displaying at all, which is a bad thing, okay? So these are the changes. Now to test the changes, I'm going to save the scene, okay? We're going to save the scene here. And then let's check it to see if it still works. So first thing we always do is make a change, we test it, and then we test it again. Okay, we keep testing it, and then we're going to put this up on GitHub in a second. But this is kind of a small change, it's a bit of a small change. To be honest, when I get back to the summer and we do some updates to our STL engine, hoping that Alex and I can do that, then hoping that we can get in there and do that. Okay, set condition. So set condition is triggering somehow, right? It's in the scene update method, scene update. It's triggering set condition, right? So that is happening right here. I've got these really weird phantom updates. So under update, right, it's going to try and set condition to something that hasn't been initiated. So we need to stop this from happening as well. So as location, set condition, there is no something that has anything to do with anything. So we're just going to get rid of this reference as well. Something we forgot. Let's try that one more time. Again, we always want to try and make sure that things are okay and they're working. Okay, now what about this one? This is specified task system.io is not working. Okay, so again, it's a weird bug that we get some really weird bugs where it says the task executable cl.exe cannot run. It's an exception. You know, that's okay. Again, one thing I'd like to try is making sure things are going. Sometimes you get like these weird errors. And you notice that what's going to happen is nothing is showing up. This is failing. This is good. This is a good thing. Why? Because I never said that the default is to be visible like we did with everything else. If I go back to GameObject.h, we have a constructor, right? And in the constructor, what we want to do in GameObject.cpp is we initialize. One thing we initialize is that it's enabled, but we need to also initialize that it's visible. So visible is true. See, first make it fail, and then make sure it works. Let's see how this works. Run it one more time, and if everything works, then we should see everything being displayed. Yay, pretty cool, like it, right? Still got this going on, we're all good to go. So that is us checking. Let's do one more change for the final test. The final test to make sure our little feature went through is, I want to go to the start scene, start function. And what I want to do is I want to make my obstacle number 2 and obstacle number 3, I want to make them invisible. So the way to do that is m_p obstacle number 2 dot set visible to false. Okay, so we can make that invisible. All right, and we'll do the same thing to obstacle number 3. So we can turn them off if we don't want them to show, but they're still going to physically be there. Even though they're not showing up, they can act still like obstacles. So they're turned off. And if I run everything, now they're not turned off, they're just invisible. So the difference between invisible and turned off. We could have also elected to turn off the alpha transparency, but there's no point doing that. So you can see that those turn off, and I can turn them back on by just clicking this as visible. So I can turn them off and on. This mechanism is also something we can use in IMGUI where I want to check on something that's visible or invisible. Okay, so very good functionality. Awesome, so I've done this. This is a great time to put this up on GitHub. So again, I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. It's going to show me the things I've just changed. A couple of items, and I'm going to say something like added visibility option to game object class. Okay, so that's what I do, and that's available to every game object now. You can turn any game object visible or invisible. So home, sync, and push. You'll have that functionality up online in just a moment. So Sinan says we need to give a value to is visible. No, it's set visible. Is visible is a check. That's how we get. It's a getter. We could have renamed it to get is visible and set is visible. I just called it set visible. You could also might want to, in future iterations, maybe we'll have set visibility, right? Oh yes, m_visible. We definitely want to set a default value there to true, right? So that's what I did here in the game object CPP, m_visible to true, because we need to set some kind of value, whether it's true or false. My recommendation is we set it to true, and then what we can do is, just like we did with enabled, by default, all game objects should be visible and enabled. Make sense? All right, so that is your game object superclass. We're not touching that for a while more, and that's the first change we wanted to make. So now that we have a mechanism for turning things on and off, I can show or hide whatever I want, and I want to be able to do that later on inside of our functionality. Let's continue. Let's continue to add additional features. Okay, so I'll keep this the playscene.cpp up, but we'll get rid of the scene class. We don't need those anymore. Next one, I want to make a new class, and I want to put it inside of my game objects, right? I'm going to right click, and I'm going to add a new item, okay? And the new item is going to be a .h first. We're going to call this Pathnode. We've had different kinds of nodes, different kinds of tiles, but we're going to make this a Pathnode. And it's going to go inside of the src folder, like normal, pathnode.h. Okay, I'm going to click add. And I'm also going to immediately add in a new item, which is pathnode.cpp. Let's add that in. Pathnode.cpp. We want to include pathnode.h. All right, there we go. So pathnode.h. Let's do the regular stuff we normally do. If not define our guard, right? Path_node. Then we want to define path_node. And we want to end if defined path node. Okay, so that's what it is. And then what we're going to do with this one is a couple things. One, make a new class, Pathnode, which derives from a public agent superclass, right? Let me explain why the agent for a second, okay? Because you're going to say, wait, it's not contextual. You're right. If you said that, you'd be right. So why agents? Let's go to definition and check that out. So if I go to definition for agent, well, the great idea behind agent, actually, it's inside of our decision tree agents, right? and this is in our core components. We have an agent.h. We have an example of an agent, which is a ship. So what is an agent? An agent is a display object, right? And it also has additional features like get transform, get target position, get current direction. We can get line of sight distance as well as has line of sight distance. I can also get current heading and get line of sight color as well as all the setters for all those things. And that gives us additional functionality that we need. Now I've called it agent, but maybe we could call it something else. I don't know. But the functionality that I want is right here. All this stuff that I got right here, maybe even extra. What did I do for the condition error? I just removed the condition error from, the only thing that's in my update now looks like this, and that fixes the error. Okay, Sinan? All right, so this is, let's go back to Pathnode.h. So Pathnode.h, I want to make two parts, a public area and a private area, just like normal. I want to create a Pathnode constructor and a Pathnode destructor, like regular. And I also want to get all my inherited class members, missing members. I want to get that, which creates all the lifecycle functions from display object. So display object lifecycle functions, because that's what they are. Draw, update, and clean, as an example, right? Those are all the ones we need. And that's really my path node more than anything else, right? It's kind of straightforward. And you're going to see how we're going to use this in a second. But first things first, as we say, right? So again, not going to change much here. Let's implement these. So again, I'm going to go here, click onto it, go here, and generate definitions by declarations in the CPP file. We're going to set our destructor to default, just like normal. There we go. And in here, we're going to do some changes. You know what? We have a great example of this in ship.cpp. Let's bring ship.cpp in the scene, and let's make it split screen for us. So I'll take that ship.cpp and put it to the side here, right? And you can see now that we have split screen. We have our ship, an example of an agent on the right, and we have our path node on the left. I'm not going to need a texture manager at all, but I am going to need a width and a height. Let's do that. So let's set width and height. I'm going to set it to 10. All right, so it's going to be a width of 10 and a height of 10. Okay, so it's going to be a little tiny or kind of a little square. That's going to be visible when I want to make it visible. When I feel like seeing the path nodes, I'm going to show it. How did I split? I pulled off. So let's say I have a tab here, Sinan. I just took the tab, I tore it off. And then notice that there's this little cross right here. You can choose where you want to park it. So if you hover over this part of the screen and let it go, it actually parks it right there. That's how you do it. Awesome. All right. So again, I want to do set width and set height. And I also want to type, but right now I only have a ship. Let's go to definition for this one. I want to add a new type under plane. It's going to be called path node. That is my new type, which is going to be under game object type. Game object type. Okay, so notice that our ship, all I did to get there was I right-clicked on my set type, and then I went to definition, go to definition, which flashes me to this. Okay, and I just added path node, okay, because I want to make that a path node. So I want to definitely set type in my constructor. So set type. And we're going to say path node. Nice, nice, nice. Position, velocity, and all that stuff, I really don't care about too much, but let's set some defaults. So I'm just going to grab this. So kind of go over here, grab this part, and place it in here. My position is going to be 0, 0. So I don't have to do this, because if you remember that by default, everything kind of starts off kind of initialized at 0, but it's okay. And the same thing goes with is colliding. So is colliding is definitely false. It's not going to collide. All right, so those two things we're just going to set just to give a message to whoever's reading this to say, hey, we're not colliding and there's no transform anything. These things I also want to grab, except for min turn rate. I don't care about that, but these things I want to grab. Set current heading, set current direction, set line of sight color, all this stuff I want to grab. And then pull this into here. We don't have a turn rate because we're not a ship, so we're going to get rid of this. And we're going to set facing right is okay. We'll leave this current angle as 0. Now, line of sight distance. Remember that our screen is 800 pixels by 600 pixels, right? So we don't need a heading right now, but we will, Miguel, because we're going to point to the target every single time. You'll see what I'm talking about in a second. So for now, all I'm going to do is set this to 0, set the current direction to 10, which is facing to the right for now, just to set something there. Line of sight distance, I'm going to make it 800. So it's going to go from one side of the screen to the other, most likely. If you really want to make it bigger, you can. All right, so you can make this 1,000, but that, is something that is going to take, kind of 1,000 pixels across the screen kind of stuff, right? Which is something that's going to happen. You can make it even longer if you want. Remember, 800 by 600. What's the hypotenuse when it comes to pixels? So how do you figure that out? So we want it to go anywhere on the screen. So we can say c squared, right, or c is equal to the square root of a squared plus b squared. We know it's 800, right, squared. So 800 squared times 800. So 800 times 800, right? So 800 times 800. And we want to add, right, we want to add the square root of 600. So 600 square root, right? So those two things, square root of 800, square root of 600, right? Or the square of those things, right? We want to add them together. We get something that looks like this, right? Together, 1 million. We want to get the square root of that, right? Which is this. So it comes out to about 1,000, which is exactly what we're getting there, 1,000. Okay, so that's what I figured that out. 3, 4, 5 triangle, it's exactly right. Right, so if you think about this, right, it's 1,000 pixels distance from one corner of the screen to the other. That means anywhere on the screen, we're going to have enough distance. You can actually modify this if you want, but really what we're doing is casting arrays from each of the points on the screen to anywhere else, okay? Line of sight color, we're going to start off as red. That's what this color is. We could also make a color class. I haven't had a chance to do that. Certainly we can add that in later where we have a color class instead of these ugly variables right here, but it's fine. It makes sense what this is. Okay, this is a red color. So that is the path node starting off. Other things that we need to do in our CPP, right, for the path node, right? So pathnode.cpp is we need to draw something. We're not going to update anything and we're not going to clean anything, but we definitely need to draw something. And the way we would draw it is a couple of ways. One, first, we want to draw the node, right? And we don't need this anymore, by the way, but we definitely need something that does a line, draw a line, and it's going to be something like, but we're not going to do any kind of texture manager. However, I know what my little STL engine does that we've made, and we're going to include texture manager anyway, okay? Just because I know how it works, because it needs it with what we're doing. We're also going to need util, so include util.h. Let's add those in there. Path node, texture manager, util.h. And when we draw our node, it's going to look something like this. Util, hey util, I want to draw a rectangle, right? Draw rect. I want to use the transform position of my object, but I want to subtract, I want to go back half the size of my object. So I want to remove 5 from the object left and right from the initial position, right? Because if our size is 10, I'm hard coding it, but it's okay. I'm making a custom class. And then I want to use the width and the height, right, of my object for the shape of the little square that I'm making. Plus, let's use get line of sight color, which is going to vary depending on if we have line of sight or not. Okay, so that is drawing the node. Just as a debug, so let's use, we're going to draw a debug tile as well. And that's going to be used for positioning, right? We want to do this for the first time. I want to use the util function right now, which is going to be drawing a rect, and it's going to be get transform position minus glm vec2, and I want to kind of pull off, here's config, pull off the tile size. So tile size, I want to subtract tile size, and I'm also going to, so I'm going to subtract tile size from the, but it's going to be half the tile size. So if it's 40, I'm going to subtract 20. I'm going to go march back 20 pixels and up 20 pixels to draw my rectangle. So I'm going to say tile size times 0.5. And I'm also going to do tile size times 0.5. I'm drawing the rectangle again. And then from a width perspective, it's going to just be tile size. So I'm going to do the width as tile size and the height as tile size. And I'm going to stay there with a green kind of rectangle. That's what I want to draw. This is just for positioning. I'm going to turn this off later. Okay? I don't need it right now. Well, don't need it later. I need it right now. One thing to note is that my config class, I should probably also include, just in case that's going to cause a problem. Let's just do it. Config.h. Okay, there we go. Config.h, util.h, texture manager, all the extra stuff that we need. Wonderful. I've got everything that I need in my path node for now. Okay, let's save it. Now, to test it, what I want to do is in my placeScene.h, let's bring it back my Solution Explorer. In my placeScene.h, going to go back in there. I want to do a couple of things, right? I want to enable a brand new, I'm going to put in the path node. So I'm going to say path node pointer. We're going to call this just a m_p path node. This is our test, right? So I'm going to kind of make one in place and also include our path node.h. So I want to put one in there, right? And then I want to display it. Let's display it on the screen somewhere so I can check to see if my path node works. Okay? So again, I'm going to go back up to my placeScene.cpp and then scroll all the way down, or just jump to my start scene. And underneath my last thing, which is the target, let's put in place the path node. So I'm going to say m. So this is our path node test to see if it displays. m_p path node is equal to a new path node. We've done this many times before. I'm going to say that m_p path node, I want to get transform, and I want to set the position to a GLM vec2 object, which is going to be in the middle of my screen. So something like 400 pixels, maybe 100 pixels down from the top so I can see it, right? And then I want to add child, right? m_p path node. I should be able to make this path node, which is going to be like a little dot surrounded by a tile, visible, okay? And we'll be able to gauge what I need to do to modify it when it comes to creation, okay? Let's do this and try it out and see what happens. Does my path node get displayed or not? By the way, guys and girls, sometimes, and everyone else, sometimes what I need to do also is I need to clean my solution because I've changed my GameObject superclass all the way down. I've got a cascade of changes, a domino effect. Sometimes it'll crap out. Hey, look at that. There's my path node. Not sure if that's exactly centered or not. It's hard to tell. So what I want to do now is I want to draw a grid of nodes everywhere on the screen, similar to what we did last time with our grid, okay? And this way I can see each of the path nodes. I'm going to also turn off this green rectangle later, okay? It's just all I care about is this red one. Okay, so that's what you should have. This is pretty good. Our path node is functional. Let's put this up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I've added a path node, modified my place scene, and my GameObject.type.h. So we'll say added path node class. Right, so commit all, Home, sync, and push. And there you have it. That gets pushed up. Awesome. Now, what I want to do is in my placeScene.h, And we've done this before, right? Placing.h. What we did before was create something called, instead of doing a path node, a single path node, let's get rid of the single path node. That doesn't make any sense anymore. That was our test. We're also going to get rid of our adding a path node. The single path node is going to be gone. We don't want to do that here. That was our path node test, right? Instead, I want to build a grid of nodes. So inside of our placing.h, we're going to do the same thing we've done before. Standard vector of type path node pointer. And we're going to say m_p grid. We're even going to use the same name as we used before. I'm going to have a couple of functions. One of them is called m_build grid. We've done that before. Okay, so that's something that we want to do. Let's implement that function. Go to let's make that implementation. Generate implementation. There we go. Okay. So what is this going to look like for us? It's very similar to what we've done before, but just chopped down a little bit. So we're going to start by doing a tile size that's going to equal to my config tile size. Again, you can choose whatever tile size you feel like. If you want to make it tighter, it's up to you now, because it's not going to display anyway. You can make it 32 by 32 or 16 by 16. It's up to you. I'm not going to display anything, so it's okay. I'm also going to add path nodes, right? Path nodes to the grid. That's what I'm going to do now. And I'm going to do it in 2 for loops, right? So I'm going to do a for loop that has a row, right, which is going to go to config, and it's going to go to row num, right? It's config row num. We've seen this before, exactly the same. We're also going to do another inner for loop that's going to be of column type, where it's going to be of config column num. All right, so I'm just going to copy this and paste it and change this to column num, right? This one. So 2 for loops, an outer for loop, which is the row, and the inner for loop, which is the column. Then we're going to specify a new path node pointer. So I'm going to say path node pointer. I'm going to call this path_node. That's going to equal to a new path node. I'm going to kind of create a new one, a temporary one, as we go. And what I want to do with this, I'm going to say that the transform position, this is important, of the path node is going to be equal to a new GLM vec2 object, which is going to be starting off with column times tile size, column times tile size. You see this exact code in the previous thing we did, followed by row times tile size. All right, so those 2 things. So that is going to give us row column, but it's not correct. It's not correct. We're going to see how it's not correct in a second. That's why we drew the other thing. Then we're going to add child. We're going to add child our path node. All right, that's what we're going to do. And then I'm going to push it back to the grid. m_p grid dot pushback, and then it's going to be path node, right? This one. So that is setting up our grid. This is all we need to make a grid of building tiles across the entire scene. And this is going to be the effect that we want to see. Right? We want to build our grid, and we can see all the little nodes on the screen, or we can turn them off with IMGUI, which may be another little challenge, but it's fine. Clear? Are we good? Check mark if you're good, X if you're not. I'm also looking online on YouTube to making sure you guys are good. Looks like some of you are good, some of you not. Okay, I'm going to continue. So now that we have this m_build grid, what I want to do is in my display function, which is going to be my start function, let's go there. So let's go to start. Before I do anything else, I want to put a grid in place. So I'm going to go underneath my placing. I'm going to say that m_build grid. All right, and let's see how wrong this is. This will be slightly off, as you'll see in a second. Okay, so let's try this. When we run it, if it runs, then we should be pretty good in terms of displaying our grid. Yowza, right? It's off. And look how it's off. It needs to move to the right 20 pixels and down 20 pixels. Then it'll be right. That's why I drew this extra little tile around it, so we can visualize what it looks like for us. This is what you should have right now, okay? Something that looks like this. But we want to move this one down to the corner, which means I need to add 20 or half the tile size this way and half the tile size down. Let's do that now, and we do that in our build grid function. So build grid, which is down here. What we want to say is, okay, cool, I like the position idea, but we're going to break this position down into a couple of lines. So we're going to say that it's equal to a new GLM vec2, but we're going to add a couple of things. We're going to say that we're going to take our tile size and our row times tile size. I like this. But then what I want to do is I want to add our config tile size, this part, right? I want to get this multiplied by 0.5. So I can say, let us add our tile size multiplied by 0.5f. I want to do the same thing here. I'm just broken down into two lines so you can see it better. Okay. So I want to add 20 pixels to the right and 20 pixels down, which should set up my stuff in the exact position I want. And the position is very important because this is going to set off the proper rays that cast. We're going to cast rays or line of sight rays from each of the little rectangles, the little red rectangles, to our target, which is what I want to do. Okay, let's see if this works a little better now. I've just added an offset. That's what this is, an offset of 20 pixels to the right and down. Let's try this out. And when we do it, we should see a better picture. Let's see. Perfect. That's what we should see now. So everything is completely aligned the correct way, and that makes sense, right? So each of the grid, we have a 20 by 15 grid like we've done before. Everything is beautiful. So why did we do this? Because now we've aligned everything perfectly. We didn't have to. Heck, we could have left the grid, the tiles, or the actual path nodes anywhere we like, okay? But I made it this way. Let's take away the little rectangle here around. We don't need the green tile anymore. That's just for help for us. And so I'm going to go to my Pathnode.cpp and comment this line out in the draw function. One line, and then save. And then when we run it again, we'll see just the path nodes in the correct spaces, like so. Okay, so this provides us with a good visibility. So here's what I want to do. Whenever I move my target, we don't even need my ship anymore. Whenever I move my target around, right, around the obstacle, we're going to see that these things light up either green or red, depending on if they have line of sight or not. If they have line of sight, they'll come up green. If they don't have line of sight, they'll stay red. That's the idea behind it, okay? Couple things to prepare before we go on, because we set up our grid. This is a good place to put it up on GitHub, but I need to do one more thing. I'm going to go to my placing.cpp. We know we've turned off stuff from a visibility perspective, but I want to really turn them off from an obstacle perspective. So instead of making my obstacles invisible, I'm just going to set enabled to false. That's a different thing than set visible. Set enabled to false. Does the same thing. It looks like the same thing, but the difference between set enabled and set visible is set visible still updates. Set enabled disables and removes it from both the update and the render function. All right, so that's why set enabled is like literally disabling the game object from the scene, okay? I want to definitely start with that. Let's put this up on GitHub. So we added a grid of tiles or a grid of path nodes. Let's do that. So Team Explorer, Home, Changes, and I'll say added grid of path nodes. Okay, this is for testing. Home, sync, and push. Okay, a few commits. Wonderful. So how is this going to work? Let's take a look at what we've got so far. We've already created a path node class. Check. Right? We've done some path nodes will be non-rendered at game object. Check, check, and check. Right? So those things are done. path nodes will render in debug mode. We haven't done that yet. Each path node will display green when they have line of sight and red when they don't. Not yet. Can we use agent class as a superclass for path nodes? We did use it. Check. Right? Build a grid of path nodes. We did this. Check. All right. So now we're left with line of sight for each frame for path nodes and a couple of other things. Let's do this thing. How is this going to work? Well, we already have a check line of sight thing happening. So if I skip up in my placing.cpp, you have an idea of how this works. I do a check ship line of sight, right? That's what renders the little line that comes out of the ship, red or green. What I want to do is I want to change this function to be more flexible. Right now we have check ship line of sight. I want to check agent line of sight. That's what I want to do, check agent line of sight. Okay, let's make that new function. And again, I'm going to go to my placing.h and make a new function similar to this. Void m underscore check agent line of sight. And it's going to take two objects, an agent pointer, as well as a display object pointer. All right, so those are the things it's going to take. An agent and a display object. Okay? The agent, it could be a ship, it could be something else, right? Or it could be my path nodes. All right, so I'm going to go here and I'm going to go to there, and then I'm going to generate my implementation. Here it is. And I'm going to be stealing shamelessly from my own function right now. Okay, stealing shamelessly. How is this going to work? I'm going to go up to the check line of sight from my ship line of sight function, which is this ugly thing right here. And we're going to grab the inner code from it, copy it. I'm going to go all the way back to the bottom where I just pasted my check agent line of sight and paste it in there. And we have to replace some stuff by hand, guys. Please do this by hand. Don't do it by copy paste or find replace. Sometimes it comes up with some ugly stuff if you did that. So I want to look at replacing target object with object. So copy, paste, paste, paste. Uh-oh, wait. Object is being used twice. Let's undo. Right? This is the problem. Look at this. Object. I'm using object here, and this one is object. Let's rename this one to display object. So right click. I'm going to refactor, rename. Remember I told you it's ugly? To display object. Okay, so that is going to be display object. That's the first thing. So display object, for every display object in display object list, that's what it's going to be, get display list. Then I want to zoom through it. Okay, and let's change this now back to object, just to adhere to our structure. Okay, and instead of ship, we want to change it to agent. So anywhere we have ship, we want to move that to agent. So agent, agent. I'm doing it by hand because I can track every kind of mauve reference, whatever that color is. Okay, and the last one, please. Awesome. So that is those changed. I'm just renaming. I got more flexibility now. And this one doesn't make any sense. It's not ship to target distance. It's agent to object distance. Agent to object distance. So let's change this. So we're going to call this, I'm not going to refactor rename. Agent to object. Oh God, maybe I should have. Distance. Agent to object distance. It's going to light up red. I want it to light up red because those are the only areas I want to change. So agent to object distance. So I'm going to copy this, paste it here and here. Okay, so agent to object distance. This has to change too. It can't be ship to object distance. It's got to be ship to obstacle distance. That's what it would mean, right? It's a display object that's blocking. So that's the object. It's the check if the obstacle, if any, is farther than the target, which is the object. All right. So here is the obstacle. We're looping through to get through the display list to make sure that every object in the display list is gone through, all right? So then what we're going to do is agent to obstacle distance, exactly. So agent to obstacle distance. We're just renaming because it makes more sense. We're going to try and make this more generic, nicer, right? So agent to obstacle distance, let's make sure it looks right, and paste. And now we have a little bit more flexibility. If we did everything correctly, we've got more flexibility. If we didn't do anything correctly, it's going to error out, and we're going to have to check, do some checking. And I went through that check earlier today with the previous lab, so it should be okay. But again, sometimes it's finicky in terms of the way things work. Okay, so this is it. Save. Make sure you save. Okay, so let's also rename some of our comments. If the agent to object distance is less than or equal to the line of sight distance. Remember, our line of sight distance can be short, like the ship, or really long, like the path node, right? Then I want to get the distance first. And what I want to do now, again, this is not the greatest idea because I'm doing a distance check. Later, maybe one day, what we'll do is we'll optimize this by using a squared distance check, which also is usable, right? And a lot more performant. But again, for now, we're just making this work. Remember my motto, make it work. All right, and then refactor. Okay, so we're using the display list. We're looping through for each item in the display list, and we're saying, here's my agent to obstacle distance. Let's get that. So we're getting two distance checks. If my agent to obstacle distance is less than or equal to my agent to object distance, right, then what we have is we're good, right? And then I'm going to check to see if the thing that we're looking at, the display object type, is not the display object that I'm checking. And this is great because since we're checking all of the same types, they're not going to clash with each other. That means I'm not going to try and collide with objects of type Pathnode. It's going to ignore them. That's what this is going to do by default. All right, so how do we check to see if this is working? Let's use it on the ship. So we already did the ship stuff, which is way up here. Let's not do m underscore check ship line of sight. Let's use our new method, m underscore check agent line of sight. I need two things, m underscore p ship, as well as my target, m underscore p target. So that is more comprehensive, and we can comment this one out. And then we'll save. Sometimes in this point, we need to clean and rebuild. If you have errors coming up, sometimes it's easier for us to clean a project and rebuild a project because we made so many changes. Let's try it anyway. So I'm going to click play, and if everything goes well, we'll have the same functionality that we had before, broken as it was. Okay? And it looks like we're good. Why? Because this is red line. Okay, now we're going to bring up our poor little IM GUI here. Remember this issue still there. I've just hidden it before. I'll move this over here so we can see IM GUI in the top right corner. Let's move our ship down a little bit. So move it down and move my object down. We can see now that it still maintains line of sight. We're good. This is the same functionality we had before, broken as it was. All right, so that's good. So now we've known we don't need this function anymore, this check ship line of sight. Let's get rid of it. Let's get rid of it, right? Let's purge. So we're going to go to here, and we're going to get rid of this, check ship line of sight. And we're going to do the same thing in our CPP. We're going to go down to where the references are for the check ship line of sight and get rid of it all of this. And now we've replaced check ship line of sight with check agent line of sight. Let's save all. And then what we'll do is we'll run it again, making sure we didn't break anything. Sometimes, guys, we break stuff when we do just that, what we just did. And it shouldn't break, but Visual Studio is a little bit finicky in the way that it builds stuff. So don't be dismayed if it's broken. Okay, it looks like it's okay. Let's put this up on GitHub. So Team Explorer, I'm going to go to Home. I don't have green because of the nodes, I guess. Is accept the nodes as an obstacle. No, shouldn't. Shouldn't accept the nodes as an obstacle because we gave the nodes a type. Remember, and the type is going to be ignored. Okay. So then we're going to say it's going to changes. We're going to go to home, and we're going to say that we created a check agent line of sight function and placing. Okay, commit all, home, sync, and push. All right, now the big one. So now we've done individual nodes. We've been able to see everything. We need another function now. We need another function inside, not the Pathnode class. We can get rid of the Pathnode class. We're not touching it anymore. But in the placing.h, we're going to add another function. Okay? And in the placing.h, what I'm going to add is something that is check agent line of sight. We did this, right? There's my check agent line of sight. We did our build grid. We did this, right? These are our new things we added, right? We removed the check ship line of sight. And now at the bottom, we're going to add a brand new one, which is going to be called check Pathnode line of sight. So where we can use the agent line of sight, right, for each path node. Okay? And then I'm going to make that implementation. It's at the bottom, not a problem. What is this one going to do for us? Well, it's quite simple, actually. We're going to do a for each, which is a ranged for loop between our m_p grid, and we're going to use auto here, and the element name is going to be called path node. So how we read this again is for every path node in the grid, then what do I want to do? I want to think about getting the target direction. I need the target direction because remember what's happening, right? Our drawing from before. We're going to have this path node, and it's going to point to the player. The player is the target in our case, okay? Each path node is going to point to the player. So that means I've got to draw a line, a direction, between the path node and the player and normalize it. So let's get the unnormalized version. So target direction, right, is equal to the m_p target, right? This is for every node. Get transform position, right? And I want to subtract the path node, the current path node that I'm looking at, get transform, right, dot position. Oops, get transform dot position. So this right here gives us the unnormalized line. It actually draws a line between the target and the path node. I'll explain in a second, Miguel. Wait. So I get the target direction, and then I want to normalize it. So I'm going to get normalized direction, and I'll explain everything in a second. That's equal to a util normalize, a new function I made for you guys, which is the target direction. So this is going to give you the normalized values between 0 and 1 for both the x and y coordinates of the target direction. This is going to give us the direction that each path node is looking at. It's going to look at the player every single, or the target every single frame. And then I'm going to say that path node, pretty simple, and I have a set current direction. This is the agent part that I want to use. And I want to set current direction, normalized direction. I'm going to pass the normalized direction as the current direction that the path node is looking at, which is the target. Finally, once I have these in place, then and only then am I going to do this for every agent, for every line of sight node or path node. I'm going to pass in the path node followed by m_p target. Does this make sense to you? So I'm going to loop through each path node in the grid, which is 300 of them. I'm going to get the direction every frame of each path node as it points to the player, right, or the target in this case, right? And then I'm going to normalize that so that the x and y coordinates are going to be between 0 and 1. I'm going to pass the normalized coordinates to the set current direction function of the agent, which is the path node. And then when I call check agent line of sight, it's going to take the path node that I'm looping through, as well as the target, and I'm going to get the line of sight. Now, the question I had from Miguel was, how does the function know when the agent has line of sight or not? It's going to set it right here. It's right here, Miguel. So as it loops through, right, as it goes through and checks each agent, each path node with the target, it's going to set the line of sight for each path node depending on if I have a collision check between I'm using the collision manager. Remember, I'm drawing a line. It's a line rectangle check. That's what I'm doing. Line of sight check in the collision manager we wrote last time is a line rectangle check. That's what it is, right? And when I do a line rectangle check for each path node, then it's going to set line of sight here, this temporary variable, and I'm going to take this Boolean, whatever this happens to be, and assign it to the line of sight for each of the agents. When the agent has line of sight, go to definition, it's going to also change the color of the agent from red to green. Okay, that's what's going to happen. Let's see if it works. So let's save all. And if I didn't make any mistakes, it's not going to work because I have to put that in a check. I got to put that in the update function, and I forgot to do that. Let's wait till it finishes building, and then I'll do that. And finishing building is good anyway because it's what we want to see. So I want to hop to the update function, right? So I'm going to hop to the update function. So of my, not my agent, but actually my placing.cpp, let's hop to the update function. There it is. And not only do I run check agent line of sight, right? But now what I want to check, also check is check path node line of sight. So let's make this nicer. We'll put in m_check path node line of sight. And that's going to check for every single one. And there's only one that block it, just the obstacles. The obstacles still block it, right? Because we want it to be blocked by the obstacles, right? The obstacles are going to provide cover for us. Okay, let's see how this looks. Does it work? We know it built, but we never had this working. Hey, look at that, guys. Green areas, right? Where we want them. So how does this work, right? Well, and how come this part is red over here? What's going on over here? How come this is red but this is not, right? So it kind of works, right? Let's get rid of a couple things. And let's make sure that these are set enabled to false. These two are set enabled to false. But I have my target as true, right? And I have my my obstacle 1 as true. Let's get rid of my ship. So let's also disable my ship for now. So I'm going to say m_p ship, and I want to set enable to false. Let's see how that looks, and let's run it again. It's not perfect. Something is wrong up here where it says that there's no line of sight here to here. Let's move it. Again, this is part of my broken function like I talked about before. If I was to move it, so again, you can see that if I move this, if I move not my ship, but my obstacle around down here, you can see that it kind of works, right? Kind of works the way I want it to. It's almost like I'm seeing an obstacle down here that doesn't exist, right? So let's put this over here. So the obstacles are still there. Even though they're disabled, it's still seeing the obstacles in the scene because they're in the display list. Okay, so even though they're disabled, they're still there, right? For me to not do it, I'd have to remove the obstacles. Let's remove them. Let's just comment them out. You'll see how this works. So comment this one out and comment this one out. And let's also comment out the ship. So we're not even adding the ship to the display list. Nothing. And now let's see how this works, because that's the issue. Even though they're disabled. Oh, look at that. Something happened. What happened? Well, I'm trying to update the ship, right? Remember, whenever we have that weird error, we're trying to update something that doesn't exist. Like we're trying to do this, change target line of sight with a ship and target. That's why it's not working. Let's comment this out. So I just want the path nodes now. And hey, okay, that's better, but we still have this part, right? So something's not right because these ones, there should be nothing here now, nothing up here. Look at that, right? But there's definitely something down there, right? Did we not disable properly? Let's make sure we saved everything. I know it's a funky thing, but if I didn't do it properly, like see, I didn't do it here. I did it for this one and this one, not this one. That's what that is, right? It's good, it works. I'm happy. That's telling you it works properly, right? But again, there's something to be said about that enable thing. Set enabled almost like shouldn't even add it to the scene, right? In some ways, we shouldn't. And so even though it doesn't update, it's still part of the display list. It still loops through the display list and does something with it. And we shouldn't even add it to the display list. Okay, let's try this again. So going back, that's what I'm looking for, my friends. Look at that, okay? And if I bring up this now and I move my target around, it's hard to see, but you can see that I'm almost getting like a light. That's what it looks like. The red is the shadow. Look at that. The red is the shadow, the areas that do not have line of sight. And the green is the light, the areas that do have line of sight. Right? Let's draw that again. So if I move this away over, it's in real time. Look at that. Okay, this is funky, but the rest is working as they should. Look at that. All right, and that's what I'm seeing here. Okay, so that is how things should work. Okay, for your screenshots, take a couple screenshots. One like this, maybe. Move this around over here. One like this, maybe another one down here, right? Or maybe over here. So you can show that all these nodes here have no line of sight. Every red node. And does it make sense? Take a look. Do I have line of sight between this node and this? Well, it probably clips the corner right here, right? And that's why it doesn't show it. Let's put these obstacles back in. All right, so I'm not going to disable them anymore. Let's put them back in. Okay, and I want to see all obstacles in place and see what the difference is there, right? Just not the ship. I don't need the ship anymore. So let's put this back in. Now we'll see that little shadow we had there before. And look at that. That's great. So we have line of sight, and anywhere else that doesn't, in this area here, it's like a shadow. Look at that. That's almost like doing a little light. That's kind of what we've said. So this is lit, and anything that's green is in an area that's lit or has line of sight. And anywhere out here in the red areas has no line of sight. Okay, and if we try it again, I put this up, and let's say I move this around, let's say over here. Let's see what happens when I do that, just to give you a nice little effect. So we'll do that, move this over here, and you can see that depending on where I move it, it's going to give a slightly different effect to my nodes that have line of sight or don't. Guys, this is the first step. And even the nodes where I put my other objects, all the nodes where the objects are in, do not have line of sight because they're in collision with the line of sight nodes. I want you to think about these phantom rays that are being cast by every single node on the screen to the target. That's what's happening. And it's not bad in terms of performance. It's not that many nodes. There's only 300 of them, right? So it's pretty good. But you can see that there's going to be some nodes over here that have line of sight. I can probably draw a line from here all the way to the circle, straight line. Anywhere that is green, I can probably draw a line right across. It'll be very tight, very close to the edge, but I can still draw a line all the way there and anywhere in there. That's what I want you guys to get today. And why? Why do we do all this today? Well, now that you have this, then doing something that looks like this is okay. If I want to move my ranged combat enemy, like we talked about before in our lecture. So if I take my ranged combat enemy and I get hit, and I want to move it to an area that does not have line of sight, I can move it to, what did I do here? I can move it to, I meant to do, no, was that right? This one. Okay. I can move this one to over here, right? So I can kind of cut it. Okay. Why? Oh yeah, it's probably because I have to do one of these, merge down. Let's try that again one more time. And then we'll do it. And I'll explain what I'm talking about. And then a little bit more detail, right? So I want to move this over here where I don't have line of sight anymore. That's what I want to do. So the close combat enemy will choose the closest node to it that does not have line of sight. It will go there directly. So if it's here, let's say there's a node here, it'll just go boop, boop, it'll go there. And it'll wait there for a small random interval, and then it'll go to the closest node with line of sight. Let's suppose this one down here, it'll come to this point, and then it'll fire at the player again. If it gets hit again, it'll go back to the closest node that doesn't have line of sight, maybe over there this time, and then go back over there, and then fire at the player again. Then it'll go back to, wait behind cover. So that whole wait behind cover thing, that's what this thing covers, as well as other things. So then, now that we know how to get line of sight, each of these nodes has that information, that data. Is there line of sight from this position on the screen or not? Again, you don't have to make it as dense. You can make it loose. You can make it custom. You can only put certain nodes on the screen. You can design your level the way you want by placing nodes in the level that have line of sight or don't. Or you can do something that looks like this that kind of does it automatically. It's up to you. Questions around this? This is your lab 9, my friends. And we're kind of ending a little bit early today because we've accomplished our goal for the day. So a couple things. Let's just check off this while you guys are checking. We did Pathnode will render in debug mode. We haven't done this part, right? But we have done this part. Okay, so that part's done. And we have updated line of sight for each frame in the Pathnode. We have done this part. Okay, we need to turn off this. We only want to render them in debug mode. So we only want to see the small squares turn on and off. And you know what? It might be best if we program it in 2 places. So one in IMGUI, and the other one we want to do with a key. Let's do the key first, where I turn on and off the debug mode, right? Remember, I want to press the G key or something like that, right, where the grid turns on and the grid turns off, right? And when I turn the grid on, then all of the nodes are disabled. They're hidden. So I want to show and hide all the nodes. That requires an extra little function. Let's do that. So I'll say, so it really depends on the key, right? So, and I also need a little, grid, a Boolean for now, that is, the grid is visible. So we'll call this m_grid visible, right? Is the grid visible, basically? And we'll say that the grid is not visible by default. We'll set that inside the constructor function. So by default, when we go into the place scene, go to definition, we will, in the start method, go to definition. Let's just pop there. Actually, it might be faster. In the start method, right, what we want is for the, by default, when we start off, m_, the grid visible, we want to make that equal to false. So by default, we're going to say the grid is not visible, right? And then we may change this. And then what we're going to do is in our placing.h down here, we'll have a little function that toggles the grid visibility. So void m_, we'll call it toggle grid. Okay. And so if it's visible, it'll turn invisible. If it's not, whatever it's going to be. Let's make that implementation. And we'll generate the implementation for that. So we'll say that if it's visible, then it's going to be invisible and so on, right? So we're going to say that m_grid visible is equal to not m_grid visible. So whatever it was, it's going to be not. Okay, it's going to be toggling that value. So turn it off and on. And when I toggle that value off and on, right, depending on what's going to happen, when it renders these nodes, it's also going to, we're going to loop through each of these, of the grid nodes. So for, and we're going to do a for each, which makes sense. For each, just like here, Pathnode, so auto. For each path node in the grid, change the visibility, right? Path node set visibility to m_grid visible. Okay, so that's the first thing we can do. So we can change that on the fly, right? You press the button and then it'll change the visibility. We can do that by using a key. So up in the top here, we can say that we can use our input manager, which needs a little bit of revision at this point, and we'll say something like m_toggle grid. Okay, so that will be the G key when we key down. Let's try that out and see how if it works or not. Okay. So grid, and if I press the G key, no grid. Right? So that's kind of how I want it to be. So you can set or kind of hide the grid, and we can do that also with IMGUI. By the way, for IMGUI, I know we have some issues with this one. The easiest way to fix the layering is to put the display list just kind of up here, but then we have some really weird kind of mirroring, if you will, or we have these trails, and I got to fix this in the summer where I go in here and remove kind of elements of the IMGUI and make them separate. I've got a little project plan so we can fix this problem. It's a bigger fix than I thought when I first looked at it. It's the way we include IMGUI, and that's why it works the way it does. All right, so pretty cool. So then when we do this, we can draw the display list or not. And what I want to do is in the draw IMGUI function, the GUI function, first of all, let's change this to lab 9, not lab whatever it was, before 7. I was wrong. What I want to do is I want to toggle or show, kind of turn the grid off and on. I have a button to start and a button to reset, but I need a checkbox. And we've had that little checkbox before. I probably want to have it above everything else. So I'm going to use a separator first. And I want to use a IMGUI checkbox. I'm going to say if IMGUI checkbox. And notice what we need. We need a label that says grid. We'll say toggle grid. And we need a Boolean that is a static. Remember I talked about this as being a static variable that we can use over and over again. Well, this is the one that we can use. We need it to be a, like it says, a Boolean pointer, right? So if I did something like and m_grid visible, right? If we did this, that should work. It's something that's global. So if this is true, then that would change the visibility, right? So we can call m_toggle grid every single time that I click the button. Okay, that's what it works like. Let's see if this works. And if I run it, we should see the grid visibility or not. So again, I kind of turn off, I get these like really weird trails. That's okay for now. Goes away when I turn it off and on again. It clears. I got to figure that out. Again, it's kind of a summer project. But if I toggle the grid, it should turn off, on and off that, and it doesn't. Okay, it doesn't even allow me to. So why is that, right? Well, it all comes down to the update function. So the start function builds the grid, sets the grid visibility to false, right? And remember what we said? We might take this away, this grid visibility thing, right? Because what I want to do is I want to say that grid visible, right, is something that's going to be static. So just like we did before, static, and we're going to go bool grid visible, right? And then what we want to do, if we did this piece, then it doesn't have anything to do with the visibility that's up there. We can just go grid visible. Remember, we can call it whatever we want, right? And what I want to do is when grid visible changes, so too does m_is grid visible, or grid visible is equal to, we can say grid visible So this kind of receives this part, and then we go in there and change it to whatever it's going to be. All right, let's see if that works or if it's crazy. And let's run it. So should turn off. Well, we notice the checks, but the checkbox works now. And this is good, right? That works, okay. But it doesn't do anything to the grid. But the checkbox works, which is the first step. So what's going on, guys? Why is this wrong, right? So if I check the checkbox, right, then m_grid visible is on. So that should turn on. And toggle grid, let's go to definition for that. Toggle grid, right, what's happening is it's saying grid visible is equal to not mgrid visible, whatever that is, right? So I'm setting the visibility of the grid to whatever I have it on. And so why isn't this working? What can I do to make this work? Last thing, guys, and then we're going to let you go. How can I make this work? Double change, okay? So do I need this part is the question, right? So let's go back and try it again. And if we turn this on, nothing. It toggles, but nothing happens. Okay, so that didn't do it. And I want to loop through this thing. I'm going to basically say that whatever this is good. I could make it so that it passes in a variable. I could pass in the variable to change. It's almost like a state change like we've done before, where I can say that in here, to be smart, I can pass in a bool state, and I don't need this anymore, right? I can just, well, let's keep this for now. And then what I can say is this will be bool state, right? And whatever the state is what this is going to be, right? We can do this. We can say whatever the state is, that is what it's going to be for each item. If it's turned on, it's going to be on. If it's going to turn off, it's going to be off. So like to like. What this enables us to do is, if I go back up to my little checkbox, right? That little checkbox up here, I can pass in grid visible, right? This one. And I'll leave this one for now, right? So I can pass it in, and maybe that will turn it off and on. Let's see. One day when it feels like running. Okay, it says toggle grid function does not take 0 arguments. Why? So toggle grid, that's talking about up here where I took that in here. So this is toggle grid. In this case is m_grid visible. That's what it's looking for. That's what I have to have it for a key, something that passes in there, right? So whatever the value is, it's what it's going to be, right? If I want to toggle grid, I can pass in not grid visible. We'll talk about this in a second. But first, let's just get it working on the IM GUI. We got it working with a key, but IM GUI is having some challenge. Let's see how this works. So does it turn off and on? Guys, what's going on? How come it's not working? It's showing the grid. What's happening? Well, we can dissect it. If you guys aren't giving me some answers, let's just do it manually. Sinan says it works fine for him. Awesome, Sinan. I'm glad. Let's do it manually. Let's cut this out. And instead of using a function, right? Instead of using a function, let's just put it in there. So we don't have to use a function. Well, a little for loop right in here. We'll ignore all this and just go, bam, and just pass in this grid visible thing. Whatever it is what it's going to be. Okay? So we're not even going to see path node. It's going to go through each of the path nodes and just turn it off and on. Just a manual thing instead of a function. So we know it's not the function. It's causing the problem. Let's try this again. Okay. And pull this up and what the hell? It's not working. Well, we definitely don't need M visible. We don't need that. But what? It was always working the whole time, right? It's just the stupid IM GUI thing. So Okay, so that's good. So we passed in grid visible. I know it's crazy, but that's okay. But we know this is going to work now. So we didn't give it a chance. That's why it was working with you, not with me. And we're going to pass in, going back to this, let's pass in toggle grid. See, I told you things are weird. I was like, wait, this is totally should function, right? So here, let's do that again. So m underscore toggle grid, and we're going to pass in the state, which is grid visible, right? That's what we're saying. And when we run it now, we turn it off, right? Or on, okay? And it should really pick up what it is. So one thing we can do is we can say we can initialize it by grid visible is equal to m underscore grid visible to set it to something, or set it to false by default. So whatever the default is what it's going to be, right? And if we want to, we can, we can set it to whatever we want. So if I run it again, it'll be matched. So it should show, what I'm saying with this one is, when I pull up IMGUI, it should show a check mark there or not, right? But it doesn't. So it doesn't show up on what it looks like. So that's something that's a problem, a bit of a problem to fix. Let's make it so that it is, if the grid is visible, it is true. That's how it starts off. So this is checked, right? Let's see how that looks. By default, starts off, it gets an initial value, right? So now it should be show checked. And if I uncheck it, it should just kind of disable. And that's how it should work. Good. Now, what about the other thing? What about the key? Did we break that? So again, if I press the G key, it turns off, but it doesn't turn back on, right? Why? Well, it's what we said. We said that grid visible is whatever we make it. So we're going to say that we're going to pass in the opposite of what it is. If it's visible, it's invisible. If it's invisible, it's visible. Same thing. We're just passing it in here instead of somewhere else. Let's try that out again. So G key, and now the G key doesn't work at all. So that's really bad, right? Yeah, the key always does multiple press. That's what I'm saying. Our input manager, our event manager needs to be fixed. There needs to be a fix for this one. So back to the drawing board. How does this work then? We get a state, whatever the state comes in, right? We want to set the grid visible, and that is the state that's going to come in to play, right? So it works once, right, where we set the grid. And then when it comes in, we want to unset it. All right, so that means that we need a couple of things, not doing that here, but rather we want to do it up in there. So what I mean by that is back to the key, where we have our key inputs, this part. What if we put that here? We're going to say that, we're going to keep track of whatever it is. If the grid is visible, it's going to be invisible. If it's visible, it's going to be invisible. And we're going to pass in the value of the current grid, whatever it is, whatever we switch it to. Okay, let's see if this works. So again, we'll try it and keep track of it. This is for the key. Have both key and the input handy. So off, on, sorry, just hitting it multiple times. But if you work it, it does work. It's just that my key is so sensitive, it'll keep on holding it down. It'll flicker between one and the other, and that's okay. But this is way more reliable when it turns it off and on. Okay. So we kind of did it. Again, we have a kind of a shaky key going on, but we've done all of this, including this. Yes, it needs fixing on the event manager side, where I pull less, Ethan. I don't have to pull as much. Miguel, you have a hand? I see your hand up. Did you have a question? You did a lot of timers for that. Yeah, I know. You can create a timer. Nope. Okay, that's good. So that's it for today, guys. You've got everything you need. I've programmed it in for you, and you've got a lot to start with. And I think this is a good progress towards doing this. the idea of having your ranged combat enemy going behind cover, okay, and how that works. The first part is, do I have line of sight for each node now in the scene, not just for the player? Okay, that's it for me today. Good luck on your lab. How do we so Santa says, how can we do a solid color visual area of line of sight? Do you mean like a shadow? Are you talking about like this, instead of it being a grid, it's like solid? Is that what you're talking about? Like commandos, yeah. So yeah, there's a way of doing that. It's like you're creating a mesh, right? That's what you're kind of doing. And there are ways to do that where you create in real time, different areas that you're adding in. So basically what you do is you draw lines, right? You draw your line of sight lines, right? From connecting the dots. So you connect all the dots that don't have line of sight, the border. That's what you'd really do here. And anywhere that's green, you would fill, right? You would create a fill area, right? And you can make basically, it takes a little bit of coding, but basically what you do is you can take a line that basically connects all of these lines here together, and it would just look like this, right? So it wouldn't be perfect by any means, but it's like doing lighting effects, right? Where you're actually creating meshes. That's what you're kind of doing. You're doing a mesh that, and think about this as the light source, and then it's creating a mesh that goes from anywhere in the green area, connects all the edges of the green area together. So there'd have to be a edge detection between two nodes where the neighbor node and the other node is different. And so you draw a line there and a line here. And then what you do is you can create this solid area by doing rectangles, right? Or there's some great tools that are included in STL that allow you to draw solid shapes, right? And that's what you do. It can be totally done, but this is a good start. It tells you where to draw stuff. Hell, if you really want to, it would be blocky. It would be blocky, but you can always fill in the areas as well. And you can add more nodes. Yeah, you can add a bunch of more nodes. But the thing is, Ethan and anyone else, the more nodes you add in here, like this 300 nodes here, the less performant it's going to be, because we're doing multiple distance checks, right? So be careful. Yeah. So if I add more nodes in this, if I made the nodes more densely packed or something like that, it can be crazy. Yeah. Yeah, you can lower stuff. There's lots of stuff you can do, right? But this is a good beginning. And the good test for that is when you start creating your path nodes. So think about it in when you're actually building your grid, right? When you're building your grid, the tile size is config tile size, right? That's what this thing is, right? So we also have row number and column number. So what we can do is we can modify these numbers in the config, right? And when we do this, it'll change the size of our tiles. We can add many more tiles to it, like, I don't know, as much as you want. Can we run out of memory? Well, the good thing is we're not using a texture manager on this, on all the little tiles that we're displaying. No, but what we can do is it'll be slow, right? Download more RAM. Perfect. All right, so it'll be just slower. And then this is where you'd have to do some optimization. So some algorithm optimization, you would definitely change this distance functions. You'd remove these distance functions and use a squared distance, right? And then you're comparing squared distances. All right, that's going to improve your performance right there. The other thing is in this line of sight check, go to definition. In the line of sight check, what we're actually doing here is we're actually doing a line rec check, right, for every object. So if I have a bunch of things, we're doing many checks with just our line of sight check, right? A line rec check. So if I go line of rec check, go to definition, there is this other function that's happening for every line. It's checking with every other line. So again, there's definitely some optimizations that can be made to improve performance. There's tons of options here, right? So that's the kind of stuff that we want to think about. Okay, that's it for me, guys. I'll let you guys go. I'm going to stop recording this. Good luck on your lab. I think you have enough to get it done and get full marks. And I'll see you guys next week. Okay, keep your eye on the ball for assignment 4. It's just around the corner. It sounds like it's far away, but April is 2 days away. Okay, guys, take care. You too.